This
already created
conference will now be recorded.
for that. KU get pods, we don't have any pods. So in the last class, we discussed about the empty directory. What is the main drawback of empty directory? So whenever we are discussing about the pods, pods are completely stateless. What is the meaning of that? Whenever there is a deletion in the pod, automatically it is going to delete the entire empty directory also, or else the data inside the pod. So this is okay for some setup, but whenever we want to store the data, definitely that data is required. If at all, if there are any log files, if the log files are necessary, and then if for example, if there is an application running and the user is providing some data and that data is necessary, then we cannot store such type of data in the ephemeral format in the pod, or else in the stateless containers. So we have to do it as a persistence, which means permanent storage. How we can do that? So there are two ways that we can do that, but first of all, let us see how we can do with the raw volumes. Okay, raw volumes in the sense we are going to take the EBS volume from the AWS and we are going to create that. So for example, now what I can do, ku get PO. Right now no pods are running. Let me do one thing, watch hyphen n1 kubectl get PO. I'm going to create a container. Let us see here. What I can do here is uh, I just want to create a container, and inside that container I want to install some database. I want to install some database, and the database name will be what I can say, it will be like MongoDB. I am going to install the MongoDB, and we will store the data inside that database. So hold on. Hmm, this will say the topic. Okay, so mongo sh always, this is good. So I will take this. So let us create a volume in our AWS. But the point is here, let us see what happens. And after that, I will discuss about the configuration. Create a volume. I just want some 2 GB of volume is more than enough, or else you can go with the 5 GB. So let me go with only 2 GB, 5 unnecessary. But here I am selecting US East 1A. And the tag which I am going to provide here is the name tag, and the value will be, so first of all we need to provide the value as k8s. The name of that particular volume is k8s volume. And here additional tag we need to create, that is the cluster name. What is the cluster name? The cluster name is uh, so what is this, cgit. So this is what the thing which we need to provide. Kubernetes cluster is the tag which we have to provide, and the cluster name will be CGIT. Definitely we have to provide this k8s.xyz. So if we don't provide that, the volume, the Kubernetes will not understand this. Okay, when we provide the tag as cluster name and create the volume, but the point is we have created this volume in US East 1A. Can you tell me the drawback of EBS volumes? Do you know what is the drawback of EBS volumes?
EBS volumes are zonal.
EBS volumes are availability zone bounded, which means that, so when you create an EBS volume, that EBS volume should be connected to the particular server only, where you are having the server is deployed in US East 1A and you are having your EBS volume in US East 1B. That cannot be connected. You have to create the EBS volume in the same availability zone where you are having the server or else instance. So now what I will do, I will connect this EBS volume, or else let me do one thing. I'm going to write this. So here what happens whenever we are, so when a development team or else a database team person has asked for some external additional data, additional storage. So now what happens here, the Kubernetes admin or else the AWS admin, so the Kubernetes admins are different and AWS admins are different. So AWS admin is going to create an EBS volume, and he will provide the volume ID. So this is the volume ID which you have to create in your manifest. And when you create that, so you have to connect that to your instance. So if you see here, this is the manifest that we are going to write for our EBS volume. Where is it? When I go to the storage here, hmm, look at that. So here I can give the raw volume. So what I am doing, I am deploying a MongoDB. So that is Mongo deployment. The name of the deployment is Mongo deployment. how many replicas I want only a single replica. And here it is creating a container with the MongoDB. So the image is Mongo, so that it is going to create the container with MongoDB. And the volume mounts here, it is very important. So the volumes we are going to create is MongoDB hyphen data. This is the name of the volume which we are creating. And from where we are creating from the AWS Elastic Block Storage. So what is the volume ID? The volume ID is, what is the volume ID? The volume ID is, this is the volume ID. Copy this, give it over here. And what is the Kubernetes host name, which means that to which server we need to connect. Where is the volume created? Here you can see the volume is created in US East 1A. Still it is creating, hold on, it is available now. So which means that the volume is created in US East 1A, such that this volume should be connected to my US East 1A instance. What is the US East 1A instance? Here you can see, here we are having node US hyphen East 1A. What is the node ID? Copy this. So here you can see this node is created in which availability zone? US East 1A. To this node only we can connect that. So let me provide this. And if we apply this, what is going to happen here? A pod will be created. Here you can see a pod is going to be created. Echo good ku apply hyphen f hyphen, so that what happens here, a deployment, Mongo deployment will be created. If you see here, ku get a deployment. So there you go, Mongo deployment is deployed and the container is about to create. Ku get pod. So here, what is the thing that we need to understand here is ku describe pod. What is that? MongoDB, Mongo deployment. If you can see here, see there, attach volume attachment successful. Whatever the volume that we have provided, that is successfully attached to our container, to our pod. So that is the meaning of this entire command. So you can easily understand this. You know how to create the deployment, how to write the YAML code for the deployment. So the kind is deployment metadata. This is the name of the deployment, and these are the labels which I am providing for the deployment. And you know about how many replicas. What is the selector? Which label should be matching with the which pod label should be matching with the deployment. So I have given that. And here you can see this is the template which we are writing for the pod. So what is the metadata? So the pod name and pod label. And if you go down here, which type of container should be running inside the pod? So the containers are MongoDB. And here you can see volume mounts. So we are mounting this volume, whatever the MongoDB hyphen data volume, we are mounting this volume to this particular mount path slash data slash db. Now if you can see here, the volume or else the pod is created, it is running. Let us go inside the pod and create some data. Okay, let me go inside the pod and create some data. What I can do here is ku execute hyphen it mongo deployment hyphen hyphen bash. If I give this, I will be in the deployment. Now you can see here, right now I am in the pod. So if you go for mongo sh, this is the command you can give. So hold on, I think the same command we have to execute, mongo sh. Let me check out this, whether it is not available or what. We don't need to install anything, automatically it will be available. Hmm. Yeah, now the Mongo is available, still it is creating, but right now we are into the test database. Okay, so now what you can do, show dbs. This is the command which is helpful for you to show the databases that are available. Now what I am going to do here is use k8s class, or else you can give any name. So I am giving like k8s class is the database name which I am providing. So right now it is switched to the database called as k8s. So k8s is not created, the database is not yet created, but I am saying that use this term. So now what it is saying, switch it to db k8s class. Now what I want to do here is I want to insert some data. So in k8s db, I want to insert like this. Okay, so I'm inserting Fast and the Furious 1, 2, 3, 4, 5, 6, the movie names. And if you can see here, show DBS, previously it is not showing the K8s class, but now it is showing whenever we insert the data, automatically it is showing the K8s class. Now what I can do here is I can go to the show collections. What is there inside the database? So if I go for show collections, it is going to display the database table name. So inside the database, we will have multiple tables, right? Among those, it is showing you the movie table name. So if you go for show data.fetch, if I use this command, so then it is going to give me something. So here you can see db.movie.find. So if I run this command, it is going to show me whatever the data that is stored inside the movie table. Look at that, it is displaying the data that is stored inside the movie table. Right now it is good. So here what is the point that you need to understand? We have created an external EBS volume and connected to our pod on the location called as /data/db, where your data will be stored. This data will be stored inside the volume. So now let me exit from the container or else from the pod, and what I will do here is I will delete the pod. So what I can do here is I'm going to delete the pod. So ku delete pod mongo. Okay, if I delete this, automatically another pod will be created. Ku get pods. Why? Can you tell me why it is going to be created? What I'm saying, when you delete the pod, automatically another pod will be created. Why it is going to be created?
We have created replica set.
Exactly. So we have created the replica set. That is the reason the replica set won't allow the pods to be deleted. So it has to maintain the number of given pods. So it is maintaining that. It is going to create a new pod, which means that the old pod is deleted. So as per our knowledge, if there is empty directory, that the data will be deleted. When we delete the pod, automatically the data will be deleted. But as we have connected the volume here, EBS volume here, now here you can see ku get pod. Now let me go into this pod. Ku execute hyphen it, and the pod name is mongodb hyphen hyphen bash. When I go into the new pod, sorry, bash. When I go into the new pod, let me show you mongo sh. Mongo sh. So we will be in the test. Use k8s class. Okay. Now show collections. So if I previously, when I give the collections, it is not going to show you anything, but now show collections, we are having movies automatically there. And if I go for show or else db dot collection dot find, if I give this command, it is going to display me the data inside the movies. Hold on, sorry, movie, it is movie, right? So I'm giving collection, my fault. db dot movie dot, the table name is movie, and find. If I give this, it is going to display me the content inside that. So which means that you can clearly understand the pod is now having the data. So old pod is deleted, but still we don't have the deletion of the data we are having, which means that temporary data, ephemeral data is not there. We are having the persistent data. So this is how you can connect the EBS volume. But there is a problem here. The problem is whenever we want anything, so every time we have to contact the administrator, AWS administrator. So I want these many number of volumes. So this is the problem every time. That is the static PV and dynamic PV. There are two different types of persistence volumes that we are having. Here you can see persistence volumes versus, so static. So tomorrow we will see about the dynamic. Static PV versus dynamic PV in KDS. So we need to discuss about this. What is the static PV? Static PV in the sense, right now we are going to do whenever we want to create a additional EBS admin. For example, there is a deployment which we have to do on Monday. So then what we have to do here is we have to raise a ticket on Friday itself, so that the AWS admin is going to create some EBS volumes for us, and he will give us the volume IDs. These are the volume IDs which you have to create. Now, if you can see uh, static provisioning and dynamic provisioning, here you can clearly understand. Look at that. Kubernetes has become the orchestrator. Uh, Here you can see the idea of a container is that your applications become immutable, and meaning that when a container is running, its state doesn't change. If you want to make a change in the application, you have to spin a new version of the container. What this means in the terms of storage is that the storage becomes ephemeral. So as we discussed that the containers are ephemeral or stateless, then the storage will be ephemeral. When the container stops running, you can pretty much say that its storage goes away, or else at least eventually will you can start a stopped container, but it is unnatural. To solve the ephemeral storage containers, you have the volumes. So volumes to decouple the storage from the container. When you spin up a new container with an existing volume, all data from the previous container is still there. So this is already we have seen. Now the point is storage provisioning workflow. Currently, there are two ways to provision the storage for a pod in Kubernetes: statically and dynamically. The main difference relies on the moment when you want to configure the storage. For instance, if you need to pre-populate, so this is very important, pre-populate data in volume, you can choose the static provisioning. Whereas if you need to create volumes on demand, you can go for the dynamic provisioning. So right now we are seeing the static provisioning. Static provisioning in the sense, whenever there is a deployment which we have to do on Monday, we have to submit the requirement to the AWS admin on the Saturday or Friday itself, so that he is going to create the EBS volumes for us, and he is going to share the volume IDs. Now the point is, every time whenever we want a volume, we have to contact the AWS admin, and he will see the timing, and whenever he is free, he is going to create that, and he will provide the volume ID. But here the cost will be there. When he creates the volumes, you need to understand, when he creates the volumes, obviously for 2 days they are in the useless state only. For Saturday and Sunday the volumes won't be used, but only on Monday we are going to use the volumes. So we have to pay the bill for those 2 days also, where so whether we used or we don't use, but the volumes are created, right? So we have to pay for those two days also. This means the cost is high. And so this is not an on demand. Suddenly, if at all, if I want to create a volume, so I cannot create a volume by suddenly. I have to give a request to the administrator. He has to create the volume, and he has to provide the ID. So on demand volumes cannot be created in the static provisioning, but in dynamic provisioning we can do that with the storage classes and all the things. We can do that. But as of now, I am not going with the dynamic provisioning. I will be with the static provisioning only. So, but before you can even start the provisioning storage, your Kubernetes cluster need to have the storage class. So this is very important. By creating a storage class object, you are effectively telling Kubernetes which storage technology you want to use, and you configure in the retention policies, mounting points, and bind modes, among the other settings. Once you have the storage class defined, you can proceed with the storage provisioning. So what I am saying, so before I am going for the before I am starting the before I am going for the storage, or else before I am going for the provisioning, I need to state the storage classes. By default we will have the storage classes, I think. Let me show you one thing. Come on, hold on. I can go with the storage class, ku get storage. You can see by default you will have the storage classes. Among those, we don't want these two storage classes. These are unnecessary. These two are unnecessary. We don't want that. Wait for the first consumer. It is not necessary. Ku delete pops csi, or ku delete storage pops csi, and this is not required, and cops ssd. Okay, good. So if you see here, ku get the storage classes, we want only these two storage classes. So the storage classes will define about the type of storage. When you go here, we are having two types of storage in AWS. One is IOPS, and the other one is IOPS is for the high data retention values. So, like if I want to get the data very fastly, then I can go for the IOPS. But the cost of IOPS will be very high when you compare with the GP2. So the speed is also very high when you compare with the GP2. So these two things you need to keep in mind. So the storage class is GP2 storage class. Now we have predefined that. Now what I have to do here it is clearly stating that, so what they are saying, before you can even start the provisioning of storage, your Kubernetes cluster need to have a storage class. By creating a storage class object, you are effectively telling the Kubernetes which storage technology you want to use, and you configure the retention policies. So the static provisioning workflow as follows. Create a persistence volume. So first of all, we are going to create a volume, and that will be claimed. So if you at all, if you are having an insurance and if you want to get that money, what you have to do, you need to do the insurance claim. In the same manner, here also you are creating a persistence volume, and if you want to get that persistence volume, you need to go for the persistent volume claim. So see that, create a persistence volume that have the multiple, that has the volume properties like capacity, permissions, and class. And here what we are doing, create a persistence volume claim to request the storage and bind to the persistence volume. Okay, and configure the pod using the volume claim. So whatever the claim that we have done, with that claim we are going to create the container. Okay, so this is the dynamic provisioning which we will discuss in the next session. With that, with including the EFS configuration, multi availability zone. Right now we are doing with the persistence volumes only. So now let me create a let me create a volume for you. I'm going to create a volume. So I got a request from the Kubernetes admin, so that I have to create a persistent volume. So create a persistence volume. I will go with only 2 GB. That's more than enough. Okay. Or else, if you don't want to do this here, simply you can execute this command also. Uh, Let me check out. I just need to see one thing. Yeah, this is the one. So if I execute this command, AWS EC2 create resources. Hmm, Let me execute the command here. So what I'm doing, AWS EC2 create volume. I'm going to create a volume with the type GP2 and the size is 2 GB, and in the availability zone US East 1A, and the tag should be specified as resource tag. So Kubernetes clusters, and the name is PV1. Okay, this is good. So when I give this, automatically a persistence volume is going to be created. So here you can see, let me go to the volumes here. PV1 will be there. There you go. PV1 is available. And if you want to create another PV, also you can create that. Just give me a second. If you want to create another persistence volume, you can create that. How you can do that? I want an PV2. Simply here you can provide PV2, and the size is somewhere like 4 GB. I'm just creating two persistence volumes. Look at here. I'm going to create another persistence volume, and now what I can do, this is a 4 GB, and what is the volume name? PV2. Okay, good. Here you can see we will get another persistent volume. See, again I have to do it manually. So as a AWS administrator, so I have a AWS account and I am having the Kubernetes configuration, so I am doing like this. But in companies it is not going to happen like this. You need to raise a request, then only the administrator will create the volumes for you. You need to keep in that mind. So now we have our persistence volume created. Next thing is we need to get that. So here we are having the EBS volumes. Try to understand this. These are not the persistence volumes that we are creating right now. We did not take these two volumes into the Kubernetes clusters right now. We have created the volumes in the AWS account. Try to understand. So now here you can see, if I go for AU get PV, PV in the sense or else persistence volume. Right now, see there what it is saying, no resource found. There is no resource. So which means that volumes are not yet created in the Kubernetes cluster. Inside the Kubernetes cluster, we don't have any volume. So, but in AWS, we are having that. So administrator said that I have created the volumes for you, and these are the volume IDs. He is going to provide me the volumes and volume IDs for me. So now what I have to do, I need to go for the pv.yml. Look at here. I am going to create a persistence volume, and the label is, and AWS PV1 is the label, which means that the name of the persistence volume which I am going to create is AWS PV1. And here the storage class name is, I am going with the GP2, general purpose 2 type of volumes. And retention policy delete. So what is this? We are having three types of retention policies. One is retain, delete, and recycle. So retain in the sense, if the persistence volume claim is deleted, then still the data will be available in the persistence volume. If I go for the delete, if the PVC is deleted, automatically the data will be deleted. So that is altogether a different concept. We will learn about that. But as of now, I will provide you in the clear documentation. So whenever I am submitting you the Kubernetes documentation, I will provide you there. And how much storage I am taking? I am taking 2 GB only. And here you can see access mode is read write once, which means that we are providing the permissions as read and write, and that should be connected to a single instance. Read write once in the sense, it will be connected to a single instance. There is a connection called as read write multiple also, so that we will see in the next session. But as of now, I am connecting it to the single instance, so that is the reason why we are getting read write once. And the volume ID is, so what is the PV1 volume ID? So let me copy this and paste it over here. This is the persistence volume 1. And here I am going to create the persistence volume 2. So here you can see I'm going to create the persistence volume 2 with the storage size of 2 GB only. So what is that volume ID? If you can see, the persistence volume 2 ID is, this is the persistence volume 2. So these are the two IDs. Now let me create the persistence volumes. Okay, echo you apply hyphen f hyphen ku get pvc, get ku get pv. So when you see here, two volumes are created. Even though the second volume is of size 4 GB, I am taking only 2 GB from that volume. For my consideration, I'm just giving 2 GB, but 4 GB will be utilized. I will show you. But as of now, here you can see access mode is read write once, and the reclaim policy is delete, and the status is available. And here you can see claim, there is no claim. Okay, so the next one is storage class is GP2. What are the volumes that are created? Those are of the GP2 storage class, or else there will be IOPS also. IO1 we can create the storage class. Okay, that's fine. Now let us go back and claim it. Now we have the PV, persistence volume is available, so we don't have any claims. We need to claim that volume. Okay, so what I can do here is I can go with the PVC. Look at here. So I'm going with the PVC. What I'm doing, app version 1. Let me copy this. What it is saying, I'm claiming it. I am not, especially I'm not giving any PV name here, guys. You can see here. So what is the code that is saying here? Look at that. So I am using version 1, and the kind is persistence volume claim, and this is the claim name, but task hyphen pv claim 1. This is the name of the claim, and the access mode will be read write once, and the storage class is gp2. And what is the size? I am going with the 2 GB. And here when you see the code here, am I mentioning any persistence volume name here, like AWS PV1, AWS PV2? I am not mentioning that. So what happens here, persistence volume claim will randomly pick the volumes. So see there, AU get PV. So it took PV1, but sometimes it is going to take PV3, PV4, if at all, if you are having multiple again. So I want to claim the second volume also. So for that, what I can do, persistence volume claim 2 and GP2 and 2 GB KU apply. Okay, good. So we have the persistence volume 2. If you see here, two volumes are claimed. Claimed in the sense, the persistence volume is asking, or else the claim is asking, I want these two volumes. So okay, they have provided this. What persistence volume will do, whether it is going to store any data, persistence volume claim doesn't do anything. So we have to create a pod. Now here you can see We are going to create a pod called as MongoDB. Again, coming back to this, you can go with the any application also. I'm going with the Mongo, and here I'm going to mount that. Let me delete these two. We are having MongoDB1. The name is MongoDB1, and persistence volume claim name is task PV claim 1, and we are having task PV claim 2, and I don't want these two. Let me delete them. Okay, PV1 and PV2, where I have to connect each and every volume is in US East 1A. So I have to connect to the instance that belongs to US East 1A. So I will go with this, and this is the instance ID. Mhm. If I provide that, now what happens? The PV claim, whatever the claimed data or else whatever the claimed storage is there, that is going to be connected to your pod. Now let us provide this echo. When I give this ku apply hyphen f hyphen, so that sorry, where I have done the mistake. Hold on. Echo ku apply hyphen f hyphen. Come on. Error in validating the string. AP version not set. Echo API version is not set. So here we don't have, we have version API. Okay, good. So now let me copy this, and I'm going to work it out with like this. Ku apply hyphen f hyphen. Hmm, good. Now the deployment is created. Ku get a deployment. Okay, MongoDB is there, or else ku get pods. MongoDB will be running. Okay, here you can see this is the DB which I am running. Let me do one thing. Ku delete. So two deployments are there. Ku get deployments. Here we are having only one that is created 25 minutes back. Let me do one thing. Ku delete deploy Mongo deploy. I don't want this. Both the names are similar. That is the reason. Ku get deployment. So right now we don't have anything. So let me do one thing. Echo. Again, I am going to create this. Okay. Ku apply hyphen f hyphen. Okay, good. Ku get a deployment. Okay, that is good. Ku get pods. So we have a pod that is about to create. So this is what, when we go into this, so what is the climb that I have taken? The climb is only 2 GB. If you see here, for both the persistence volumes, I have taken 2 GB only. But what is the volume size? The volume size is, one of the volume size is 4 GB. Here, if you see here, we have created two volumes, that is PV1 and PV2. PV2 size is 4 GB, but we have taken 2 GB. But we are requesting for 2 GB. It will provide only 2 GB only, but for our understanding, it is 2 GB. But when you go into the container, it is going to display 4 GB. I will show you that. Hold on. So whether the container is created, come on. Okay, you describe a pod Mongo. So volume, mount volume, wait for attach failed for volume AWS PV1, get error volume attachment. What it is saying, API group storage.io, no relationship found between this and the object. So there is no relationship. Why? Hold on, guys. I think I have made a mistake here. What is the node here? IB38. Okay. So do we have the same node over there? So let me check out the node name. So if you see here, what is the node name? If I go back to this US East 1A, the node name is IB03, is the same one here. But why it is coming like this? Hold on. Let me copy this. So when I copy this and I am going to paste it over here, the same thing is node selector is the same. So we don't have any problem with the node selector. We need to get this out. But anyways, the problem is why it is not getting, it should be claimed. Hold on. Again, ku delete deploy MongoDB. Okay, echo ku apply -f hyphen so that the creation is done. Ku get or else ku describe pod, that is Mongo. Successfully assigned the Mongo deployment. Okay, mount volume attached has been deleted. Hold on, pv2 volume attachment has been deleted, but I'm getting the problem with the pv2. So what is there? Volume attachment storage class. So it is saying that cannot get the resource volume attachment API group storage k8s cluster scope is no relationship between instance and this object. So why it is saying there is no relation? We need to have this relation. Okay, let me do one thing. I will go with the single volume claim. What is there? I'll go with only single volume claim. Task pv2 claim. I will delete this MongoDB2. I'll go only with the single volume claim. Okay, let me copy this. Echo ku apply -f hyphen ku describe pod Mongo deployment or else you get pods. One is running from the 88 seconds. Let me check out with this. You describe pod, that is a Mongo deployment 56. So if I go with this successfully, okay, 2 minutes I've been. Yeah, claim is like an attachment. So now let us see here. The volume is successfully pulled out. Whether we are having that volume or not, I need to check out this. Let me see. Ku get the pods. Here one pod is running. So this is the pod. Let me go into that. Ku execute -it MongoDB 56 hyphen bash. If I go into this volume or else into that container, if you see df-h, look at there. Here we are having slash data db, which is of 2 GB of size, and here we are having slash temp db1. So if you can see here, previously what we have done at that, we have a volume claim task pv volume 2, which is attached to the temp db1. So what is this task pv volume claim to? We have claimed that for the 4 GB of memory. So which means that we got the 4 GB of memory. For saying, it will be shown as what is the pv volume that I have selected. The pv volume is selected as 2 GB only. So here you can see it is showing as 2 GB. I'm claiming 2 GB only, but by default we are having the EBS volume of 4 GB. So if you want to use, you can use the 4 GB also. Okay, so that's about your PVs. Now when I go back here, when I come out of the volume over here, ku get PV, here you can see climbed is there. Now ku get PVC, it is also there. Now suddenly if I delete the deployment, what I'm going to do, ku delete deployment hyphen all. I'm going to delete all the deployment, so that what is happening, the pod is deleted, so that volume claim will be retained. Volume claim will be retained, but the data inside the persistence volume will be there. Here you can see, of course we did not provide any data, but I just want to show you ku get pv. So here one thing you need to understand is, or else ku delete pvc. I'm going to delete all the volume claims also. When the volume claims are deleted, here you can see, there you go. Previously the status is bound, now the status is failed. which means that the point is whenever we are deleting the claims, so first the pod is deleted, still the claim is available. Now when I deleted the claim, inside the persistence volume we will have the data, but the persistence volume doesn't know to which it is claimed. So it doesn't know to which the data is claimed. So now the persistence volume will be showing you in the state called as failed state. So what I have to do, I have to send a null into that. So this data belongs to no one, so you can delete the data. If I send that, then only it will be coming back into the bond state. So now let me go back and do this. I'll execute this command. See here, what I am doing here is claim reference is null. What is this claim reference null? If I have to show you, see that ku explain pv dot spec. You can see here there is an option called as claim reference. Hmm. There you go. Reference is a part of bidirectional binding between the persistence volume and the persistence volume claim. Expected to be non-nil when bounded. So which means that there is a interconnection between the volume and the volume claim. If the volume persistence volume is there and volume claim is not there, which is previously bounded, if that claim is not there, then the persistence volume will say that I am unable to find the claim. I am unable to find the who is going to take the data, so it is going to show you as failed. Now if I want to get my persistence volume back, what I have to do here is I need to repatch it. Here you can see I'm going to copy this command entirely. I'm having only two, right? Two. Of course it might be overwhelming for you guys, I understand that, but here you can see for I in 1.2 I'm claiming claim reference as null. What they are saying, you cannot set the claim reference as null, but here we are setting the claim reference as null to get back my persistence volumes, to delete the data inside the persistence volume and reclaim the volumes. See there. Mm, for I in 1.2 to kubectl patch pv aws hyphen pv dollar I, okay, hyphen p. I'm patching that. So how I can do that? Specification, under specification we are having claim ref colon. I'm going to provide null. Simply you can do like this. Okay, good. And if I go for done, mm, mm. So again repatched. So if you see here ku get pv, now it is in the status available. Now the persistence volumes are available, everyone can claim that. If you create a claim, you can claim this persistence volume. So this is what the persistence volume is all about. So first of all, what we have to do, we have to raise a ticket for the AWS admin. AWS admin will create the volumes for you and he will share the IDs for you. And later on, what you have to do, you have to create the PVs. So again, directly we cannot take the volumes. It is like whenever you purchase a hard disk, can you directly store data? You cannot store data. What you have to do, you have to format the disk, and after formatting the hard disk only you have to store the data either in the ntfs format or extension format. Then only you can store the data. In the same manner, when the ebs volume is given for the kubernetes cluster, directly we cannot connect it to the kubernetes cluster, but previously we have seen how we can connect. But anyways, if at all, if we are going for the persistence volumes, so here we have to first take the disk and convert them into the persistence volumes. And then what we have to do, we have to claim it, or else any if there is another deployment is there, they can also claim that. So I want this persistence value, so I am claiming it. So like that, anybody can claim the inside the kubernetes cluster, anybody can claim the persistence volumes. No, I am claiming that, so I can access that persistence volume. And with that claim I am attaching that to my pod. So when I attach to that, so through the claim I am getting some data from the or some storage from the persistence volume, and that storage will be attached to my pod, and my pod can store the data into that volume. So this is called as persistence volumes and persistence volume claims. Here the point is these are the static provisioning. We can, so if at any point of time, every time we have to request the AWS admin to generate a volume for us. So if he is very kind towards us, he will generate immediately. If he is very busy, then what he is going to do? Today my requirement is that today I have to generate the persistence volume. So So we are going to create the persistence volumes and then we are going to claim them. This is the simple thing which we are doing. Okay. Of course, in the practical manner, it is something difficult. First of all, we need to write the YAML script and then we need to claim it. So something difficulty will be there. But finally, what is my requirement? We cannot go for the EBS volume. Simply, we can configure the EBS volume and then we can go for the claims and we will attach the claim to my. We are directly not attaching the previous persistence volumes. We are attaching the persistence volume claims to my pod. So through the pod we can configure that. Okay. Any questions here? So if you try to understand this, try to go through the what I can say, the YAML files, you will clearly understand this. So first what we are doing, we are creating a persistence volume, and this the claim is like or the storage class is like GP2, and here the volume will be read write once, which means that it can be connected to one server only, and this is the volume ID, so that persistence volume will be created. And after that, whatever the PV is created, I am going to claim that. How I can claim that? Persistence volume claim, and here the same storage class is GP2 and the storage is 2 GB. So randomly PVC is going to pick up one of the volume, and to that volume the claim will be done. Once the claim is done, then we can connect the claim to our pods here like this MongoDB, and here you can see the claim is there, the volume from where you can get the storage. You can get the storage from these two claims, and these claims are connected to my volume mounts inside the pod. Okay. So this is called as persistence volumes, but the point is this is a static persistence volume. So tomorrow we will discuss about the dynamic persistence volumes. Am I clear with this?
Sir, I have one question. So claim,
Mm-hmm.
that means if we have the 10 terabytes, we are claiming only 5, right? But when we
Mm-hmm.
attach that volume to the pod, still
Mm-hmm.
we can access that all the 10 GB.
Yeah, 10 terabytes.
Perfect. Okay. And I have one more thing is
Okay.
like that. So right now we have the a 3 volume or the 4 volume. Okay. But
Mm-hmm.
now we have
Mm-hmm.
only one replica. So all that volume is getting attached to that one replica. What will happen if we
Yes.
have the similar equal number of replica?
That is not, it is going to attach it to the, see here, the here it is attached, here it is not attaching to the pod volume. Where volumes are attaching, the volumes are attached to the nodes, and from the nodes we are collecting them as a persistence volumes. Are you able to understand? Here the EBS volumes are getting attached to the node. So the point is inside that, no, whatever the pods are there, so to those pods we can apply the volume. Are you able to understand? So where we are, so first of all, take from the starting, we are creating the EBS volume. So what is the EBS volume drawback? It can be created within the availability zone only. So whenever we are creating the nodes will be creating in the multiple availability zones, right?
Hmm.
So
Yes.
whenever we are creating the nodes on multiple availability zones, what we are going to do, this volume, whatever the volume that we have created, that will be connected to a single availability zone node. Okay.
Yes.
so
Hmm.
inside that node, how many pods will be created for the deployment, for the same
Let's say
deployment?
let's say 2.
If I how see inside that node, if we give three, so for example, if I go for three, then that will be connected to the only one replica, right? So if I
Mm-hmm.
want three replicas, if I am having three nodes, each node we will have the replicas created. Now that
Yes.
volume will be connected to a single pod itself. Okay. So if you want to connect to the multiple pods, then again you need to go for the claim itself. Again, you need to provide the claim and you need to sharing is not available, I think. Okay. So if at all, if you are having a single pod in a single node, that volume can be attached to that. But if at all, if you are having multiple pods and two pods will be created in the two different nodes, we cannot provide the volume. Why? Because two nodes are in the different availability zones. The process will not accept that. The EBS volumes will not accept that. And to do that, we are having an EFS configuration. With that, what we can do, we can go for the multi-pod sharing also. Okay, with the EFS volume, we will be creating a EFS volume, and we are going to share that EFS volume between the multiple pods, especially between multiple nodes of multiple availability zone, so that the volume will be shared between the multiple pods of the deployment. Okay.
Mm-hmm. And I have one more thing is like that. So could you please show me the deployment file where we are attaching the volumes?
What is the doubt?
My doubt is like that. So if we are running this a YAML file multiple time in a
Mm-hmm.
particular cluster, okay. So what will
Mm-hmm.
happen at the background? So MongoDB is getting deleted and then it is created again and then volume is
if there
getting
are
attached.
if there are any changes, then it is going to be deleted. Then deployment will not delete. Pods will be deleted and new pods will be created. If there is no change, it is going to show you that unconfigured, no changes have been made, so it is going to run as it is. If there is any change, then the pod will be
Ch-
deleted and a new pod is going
change
to be created.
change in YAML file, is it?
Change in the deployment, not
Yeah,
change in the YAML
deployment.
file will what. So change in the YAML file means what you are going to, you will change the image, or else you will change the volume name. So there are some changes. When there are changes only, then the deployment is going to be changed, then pods will be deleted and new pods will be created.
So this is what my question is like that. So my program, my image or my program is still up and running, but we need to attach one extra volume to that. So
Mhm.
how I'm going to do that? I have to go to the console and manually we have to attach that.
No need. The pod will be the container will be running. You are not doing any changes with the container, right?
Yes, we are. I'm not doing. I just want to attach one more volume.
You can attach that. So container won't be disturbed, but new volume will be attached to the container.
How we are going to do that? Through the YAML file which you have
Of
shown me
course, through the
earlier.
YAML file only. Anything what we have to make the changes, we have to do through the declarative format only and through the YAML files only.
But since we have modified the YAML file to attach one more volume,
We have
okay,
modified the volume section, not the container section.
okay.
We have
Mm-hmm.
modified the YAML file. Here you need to understand modification of YAML file in the sense what we have modified. We are just adding the volume, so the pod won't be disturbed. So the additional volume will be added to my container. That's it.
Okay. Okay, so that means if you see that line number 19, we have the containers. Okay, until unless we modify this section, the container is not
Mm-hmm.
going to be modified. Okay, if we are modifying the volume section, line number 28, okay, so
Mm-hmm.
the only this part of section is going to be executed, right?
Yes, exactly.
Okay,
So that
yeah,
will be added to your container also. So your
mm,
container, your pod won't be disturbed. Okay.
okay, got it.
Yes. Okay, chalo guys, fine then. We'll meet in the next session. We'll discuss about dynamic provisioning. So with this persistence volumes, I'm going to stop your sessions. And so Saturday and Sunday, we will be going with the, so on those two sessions at 7 p.m. in the night or also in the evening 7 p.m., I am going to start these two things. One is Helm charts, config maps and secrets. And finally, we will be winding up the sessions with the, what is that? STO mesh. With that, we can wind up the sessions. Okay. Saturday. So USB volumes is like USB hard drive, sir. Somewhere you can compare like this. So something, yeah. Where I am, yeah. So tomorrow I will tell you about the dynamic provisioning and the persistence volume, so that I can complete the storages, and then we will be going with the new concept called as, what I can say, actually on Saturday and Sunday at 7 p.m. in the night. So I'm going to go for the configuration IST, 7 p.m. IST. I can go for the configuration of STO mesh and then Helm charts, and finally we will be winding up the sessions. Okay, am I clear with this?
Sure.
Anything
Yes.
that you want to add? Okay, then. Fine, guys. Have a nice day, and we'll meet in the next session. Bye.
Thank
Okay.
you. Bye.
Bye, sir.